It's often the case in electric motor applications that some speed reduction is required. And the reason for that is because we typically want a lower speed, well, not necessarily want a lower speed, but we want higher torque than the motor can provide. And for that reason we use gearing. In this video we're just going to examine a gear pair. So we have this input shaft, which is connected to a gear, and then another gear to which we have an output shaft connected. And the input gear rotates with displacement theta 1, and the output gear rotates displacement theta 2. The two gears have different sizes, so the radius of the first gear we'll call R1, and the radius of the second gear R2. So one thing that we know about the two gears, since they mesh together, is that the distance traveled at the circumference of gear 1 is, how does that relate to the distance that the circumference of gear 2 travels? It's equal to the distance traveled at circumference of gear 2. Mathematically, that means that R1 times theta 1, where theta is a displacement, is equal to R2 times theta 2. And that gives us a ratio between any displacement of gear 1 and gear 2. It has to be equal to the ratio of radius 2 to radius 1. Now gears have the same pitch, or in a gear pair, which gives you the density of the teeth, and so this ratio R2 over R1 is the same as N2 over N1, and where N sub I is the number of teeth on the gear. So N2 is the number of teeth on gear 2, and N1 is the number of teeth on gear 1. And this is one way to calculate the gear ratio. And that is denoted here by the letter N, capital N, and it is defined as the speed of the input shaft divided by the speed of the output shaft. And this is equivalent to the number of teeth on the output gear divided by the number of teeth on the input gear. And one thing to note, because the power in is equal to the power out for an ideal gear pair, then, and since the power is a product of speed and torque, angular velocity and torque, then the input torque over the output torque is equal to 1 over the gear ratio. So speed in over speed out is equal to the gear ratio, but torque in over torque out is 1 over the gear ratio. Now we will look at additional topics dealing with gear pairs and how they affect the motor and the load to which they're connected in future videos.